for having me at the NOTS IoT community portal, and let's have a nice conversation about doing IoT with Microsoft Azure IoT and with Microsoft Fabric. And I will talk about doing stuff with maps and ontologies if it works, because both are in public preview at this moment. My name is Sander van der Velde. I'm from the Netherlands. That's why I'm wearing this orange cap. And I'm a principal IT architect at STD Group in the Netherlands. But I'm also a dual MVP, both on Azure IoT and real-time intelligence. Well, it's so easy to combine that. So why not do both? Let's have some fun. The agenda is quite simple. I will give a very large demonstration about how to build an end-to-end solution based on positioning data and using Fabric. I'm not sure if Fabric already mentioned or demonstrated here, Pete.
Say again, sorry?
Is Fabric already demonstrated here at the MVP at the
Yeah, I think that might have been part of Christoph's. But you've done it, haven't you? I thought you'd already given a talk
Oh,
about Fabric.
I have no clue what I've done in the past, so
Yeah, I think it's been done. But
I
we
only
always
look
welcome talks,
forwards.
so you know.
But we will try also to do something with ontologies and data agents, if needed, with screenshots, because ontology gave me a 500 errors at some point. So that's why I have some backup screen dump. So let's work with that. So for those who are not familiar with Microsoft Fabric, it's a low-code and no-code experience for doing stuff with data. If you have seen Power BI in the past, it's the same UI, the same experience that you work in a browser and start doing stuff with data. But now you suddenly can also start creating databases, or you can do something with analysis or with data factory within the browser. So you don't need a cloud engineer. You, as a data engineer, are picking up that role. You will do stuff yourself. And next to all the goodies which are there in Fabric, there are dozens of items to work with. There's also a real-time intelligence part, which is a very large part of it. So suddenly I see that customers from me, they figure out that, hey, um, there's this real-time intelligence part in Fabric, so I can work with a time series database, as seen in the database part, Event House in analysis, and we can work with data ingestion with Event Stream. And we can work with maps or with KQL query sets, or with real-time dashboards to visualize and query the data. And we can use an activator to act on stuff that's happening. So that's really cool. And last year at the Fabric conference in Vienna, Maps was introduced, which is a wraparound Azure Maps. If you work with Azure Maps, you know it's nothing more than just an API. Lots of APIs, both for building visualizations, graphical visualizations on the globe. But you can also geocode or get weather data. What Microsoft has done, they have created a map visualization, and you just say, well, there's a database, there's a table, there are the rows, and this is the GPS location, and you get the bubbles on the map. Or you can say, I have geo shapes, and you have a line or a circle or a polygon. So that's what we are doing with maps. just low code, no code fun with location data. And we will see that in a moment. Because I came up with this very interesting, very normal way of how to work with GPS data or with telemetry. We have a truck and it has a GPS tracker, and that can be a GPS tracker that you build yourself. Like you takes this sensor that you can buy in China for a few dollars. And this is the ceramic antenna for a GPS sensor. And you have your constraint device, your Raspberry Pi or a ESP32, GPS enabled. Really easy. Or you go for a more well, professional thing that you do something with a 4G SIM card and you stick it in a device like this one. It's magnetic, so you can put a tracker on something. Or you go for a device like this from Teltonica. It's a really nice device. And it can read both the CAN bus and the GPS location. And so it can send all the motor management data and speed and, well, everything to the cloud over that 4G communication. What we are going to do today is making use of LoRa sensors. I have this tracker. My son is driving around today with another one. I have two of them, so probably we have recorded what he has done today. But there are many more. This is IO tracker, and I don't know which company this one is. It's from RAK. So there are many sensors available. And if the data comes in, we will send it into Fabric, where we ingest, we store it in a database, we query on it, and we start working with a map or with Activator for alerting. And this will also be seen in a moment. But just for those who are not familiar with LoRaWAN, because how does this sensor communicate? There's no SIM card in here. Actually, it doesn't cost me anything except battery power to have this one connected. That's because it uses a other kind of communication that's called LoRa. That's for long range, low power devices. Think of 500 meters in the city before it needs a gateway, or 10 kilometers out in the open, or even 30 kilometers. Fun fact, this one, I had it in a bag while I was flying to Vienna. And when I looked up the data later on, I found fixes. So it recorded communication with LoRa gateways above Germany, which is really cool. So that's how it works with LoRa. And then there's a service running in the cloud, and that cloud, yeah, from that service you can consume the incoming data. What I will be using is the Things That Work, which is a community-powered LoRaWAN a network. You can register gateways like this one. This is a mobile gateway that I always have with me to communicate if I need a LoRa gateway at the spot. But I have one at home, and we're using that one. And we can have sensors connected. And because I have this gateway here at home, basically my whole neighborhood can make use of that same hotspot. It's open. I see messages coming in, but I'm not aware of what the body is, what it means, and from who it is. But it's forwarded to the Things Network public gateway. So actually, I'm part of the network. So if you want the Things Network in your neighborhood, just install a simple gateway. They are not that expensive. And as you can see, around Nottingham, there are quite a few gateways already. So why not start using it today? So, hey, we've had the Lorawan introduction already, and there's a lot of stuff that I will do, but I will not do it here. I will make use of it using a demonstration. So I have to switch over. I think, no, not to this one. I have to switch over to this one. Because this is the portal that is supported by the Things network. They call it the Things stack. And as you can see, I have a number of sensors. I have quite a lot of sensors collected over the years, including those trackers that I have. And as you can see, I have two of them, and well, they are communicating every few minutes. And if I look at the live stream and we look at a message, let's see what's done. We will see, let's click one more time. You see that I get a payload load up to 52 bytes, but this is the payload that we get right now. But there's a automatic transformation available, which says, well, okay, this is the positioning status, the battery status, and something with the event. But let's pick another one. Let's look at this one. Here we see a latitude and a longitude and a battery status at 83%. The fun part is that we also know from which gateway this message was coming. It's someone's RAC 5146 whatever, and I also know the position if they filled it in, and I know the quality of the RSSI, the quality of the communication, so I can calculate it back to the distance roughly. So I can do triangulation if I'm a little bit lucky. Let's see if there's actually, look at this, there's a second gateway in here. So this is really cool. This is stuff that comes in. But yeah, then the messages are here in the portal. While I have set up an IoT hub in Azure. Let me refresh the page. A little bit of luck. There it is. I have an IoT hub. And as demonstrated already by Pete, we can ingest the telemetry, as we see here. And those telemetry messages are coming from devices that are registered, like device like this one. I have quite a bunch of it. And as you can see, all have a strange code. Some had a name in there. How is that possible? Because in the portal from the Things network, I set up the integration with the Azure IoT Hub. And if I expand it, I have given it some credentials to my IoT Hub, and I have said, if a message arrives, send it as an event to the IoT Hub. It could even be a reported property on the device with the same name as this device in the IoT Hub. And you can do other stuff. You can basically send everything what's happening on the portal to the cloud. But fun fact is that this is an IoT hub key. This is not a device key. This is an IoT hub key. And this is one that's quite powerful. The portal from the Things Network is capable of creating devices, registering devices. If I have a new device, I just put it in the portal from the Things Network. It will automatically also be generated on the first message in the portal from Microsoft, which is very convenient, including two-way communication even. I can also send commands back to the devices. So we have the devices arriving. That's good. And I also have set up Azure, but I didn't use Azure directly to get, sorry, I have set up Fabric, but I had put a ev- event hub in between just to see what's happening. As you can see, um, an event hub in Azure, uh, getting all the messages coming from the IoT hub, can also visualize what's happening. This is really convenient for me as a developer, but also the event hub also makes it possible to pause egress. So if I'm fixing something in Azure, I can pause or if I'm fixing something in Azure in Fabric, I can pause the egress here, do my thing, reconnect again, and business as usual. So this is really cool. Some other messages in here. So we have messages arriving from a tracker like this one to the IoT hub, and from there they are ingested in Fabric. And this is the Fabric portal. Um, it's a little bit like what we can see with Power BI. There are so-called workspaces, and in workspaces, a number of items are added. If we look at the new item button, you can see that there are dozens of items that I can create in Fabric. Uh, Data agents, notebooks, maybe you've seen it already, anomaly detection, KQL, Power BI reports. There's too much. There's too much in there. I basically limit myself today to real-time intelligence, and it all starts with the event stream, as we've seen in the. Let me get the presentation back. If we go here, the first step is event stream. Where's here it is. If you're familiar with Azure Stream Analytics, you will recognize this picture. We have sources where data is coming from, and these are forwarded to destinations. In this case, I get data from the Event Hub, and these are forwarded in plain sight to an activator to act on, and Event House to store the data. Why do I added the activator? Because if the ingest stops, it holds it for some reason, a connection is broken, I get an alert from that activator, which is really cool. And as you can see, here are the messages that are arriving. Fun fact is that we get a lot of sensor data. I have this Dargino, I have a temperature sensor, a CO2 sensor that's put in there. I also get stuff from my my Azure IoT Edge device. I have to fix that. But here are the trackers, as you can see. So data is arriving at an event house. So let's move on to the next step, and that's the event house. So for those familiar with Azure Data Explorer, that's a time series database, as we demonstrated at the flight into IoT already. It's a full cluster, compute cluster for working with time series data. And in there, I have two databases at this moment. So let's open this database. And we see that the data that comes in from all the sensors, all the message bodies, they are put directly into a table, and it's called bronze Lorawan. And if we look at it, we see all the messages coming in. There's this data column with the JSON messages that are there. And that's the raw data, and that's on purpose. If we look at the database, I will show you the flow that we are doing. We are doing ELT. We extract data from a event stream. we're putting it, we're loading it into a bronze table. So whatever comes in, it arrives and we accept it. And from there, we start to transform the data. The ambient data is quite simple. We put it in a typed table called silver ambient. That's temperature, humidity, some sensors that I have running. And regarding the stuff that we are doing with the tracker, the GPS tracker, there are a number of steps where the data is put in a silver tracker table. So if I open the silver tracker table, we see that it's very simple. There's an application. That's the kind of device. There's a device ID. I have two sensors, timestamp, latitude, longitude, and the battery level, and an ingestion time. That's how the data is transformed. Because time series insight makes it possible to automatically ingest the data and forward it from table to table to table to table automatically. And in each step, you can add extra compute to transform the data, which is really convenient. Okay, we have tables with data. Normally, you will do something like this. Then you start with a real-time dashboard, like this one. And there's even Copilot available in Fabric, which makes it possible to ask questions about the diagram that we have here. But okay, this is quite simple. We see that I have two devices with temperature data, and there's some light sensor stuff in here, and I have a battery level, but I also have a tracker, and this real-time dashboard makes it possible for me to visualize it in a map. And wow, that's cool. Those are all dots, all GPS messages from around my house, which is a little bit annoying that they are showing like this. But if I'm traveling, maybe can I zoom out? I can zoom out a little bit. Actually, I now see it's at my office today. But are there more over the last 24 hours? I see some messages all around the Netherlands. My son was driving to Utrecht for a job, and you see that once in a while he got connected with a LoRa gateway for free and dropped off the locations. But there's no order in here. I don't know if this is something like 3 o'clock local UTC time, and the other one is 3 o'clock. Okay, it's there's no order in here, and this is a limitation of this map. It's nice, but it's it's perfect for stuff. But we want to do really cool stuff with maps, and for that, I created a map like this one. And it has to refresh. This is in public preview, so sometimes it glitches a little bit. Let's hope if it works as expected. And this is the map component that we have in Fabric Maps. I can add a nice background with colors, in this case for all the provinces. That's something that I got from a set that I found on the internet. And we see the current location of the two trackers. So my son is still there, but we can also add a tail. This is me, and this is my son. So let's see. We have a tail on all the locations to show how this is working, how he was driving, and how did we do that? And then I have to go over here. Let's go back to the database. What I created in my time series database was a query set with KQL queries specifically for the maps, because I have a database full of data, and I have a query language to work with the incoming data, and it's called KQL, the Cousteau query language. Cousteau stands for it's a pun on Jacques Cousteau. He was a deep sea diver, and um, he was um, exploring the sea. So we are exploring a sea of data. So here we have the silver tracker table, and if I run this query, let's see if it's a little bit slow for some reason. I'm not sure why. I have some glitches in my capacity right now, but okay, it found the two different trackers. And this is really nice because I start with the whole table that will say there are 27,000 records in there. And then I add a funnel line. So give me just two different rows based on the maximum timestamp that we can find. And then I do the third line, which extends an extra column with the label in there. So you see the pipe signs. It's like the Linux notation. If you have commands in Linux, you can pipe them, the output from one standard output to the other one, input to the other one. Really cool. And for example, this is how we did the line strings. This is the line string, the line that we have seen for this device. I made two different queries, so they get different colors, so I can see if they're crossing each other visually. So what I do, I ask for give me information about a certain tracker, and I use that information to build a line string in code. It's JSON format with line string, etc. It's some playing around with Cousteau query language. So this is really fun. So if we know this, then we can say, well, why not put more bubbles in here? And I put all the offices that of our company in the Netherlands, some advertisement that where we are, but we are also in Eindhoven. And if we go to Eindhoven, I was at office today, and you see that there's a label and there's a name, there are colors, and I put a geofence around it. As you can see, there's it's actually a polygon, but it looks like a circle. And that's an area where when I'm at the office, something like that. And I can actually figure out how many times, this is not the best way to visualize it, but you can see I can figure out with KQL query language, give me all the line parts of the line strings, which are part of are overlapping with that circle. Yeah, okay. That's a really nice way you can visualize stuff on the map and in a very broad way. How does that work? We've seen that I created the queries in the database, and what I did was nothing more than, okay, I said I have an event house, and there's a bunch of queries in there. So if I have a query, I can say, well, show it on the map. I get a preview, and as you can see, it has a latitude and a longitude. So I just say, well, this is the latitude column, this is the longitude column, and a new layer is added, because that's how done. And I can also fix the order of the layers if I do something like this. Oh, that's not working as expected. Let me do it like this. You can see that they are overlapping or not. So there's an order in visualization. But it can also work with geo shapes, like the line string and the polygon. In this case, I have a GeoJSON column. It's called GeoJSON, but it could have been had any name. And I can say, okay, I have a geometry column, geometry column, GeoJSON, and then that's visualized. Well, if you have a layer, you can play around with the colors, you can give information about the tooltips, you can give it a label, then on the map the name is shown. You can do something with the lines, and you can actually also set the refresh. How many times this is refresh, say, every 50 minutes, you can refresh that layer. So this is basically what's offered right now. There's one more thing to show. There's also a lakehouse in here. That's a storage account, basically. And in there, I have a number of files. I downloaded from the internet a GeoJSON file with all our provinces. And from there, I created a tile set. There's this tool above that can create tile sets. And tile sets are highly optimized for showing slow moving data. And think about everything you see here in this browser. It's all done in the memory of your computer. And all the visualizations, if you have thousands and thousands of points, it all has to be rendered in the browser. So you have to be fairly smart about what you're going to do. And this can be optimized. Say, until a certain level it's not seen or it's grouped. You can work with that map in a very convenient way. And that's also the tile set that will help you with showing the right information at the right level. So, okay, this is visualizing, but how about getting a alert when I actually cross a certain situation? Well, if I go back, then I had a alert set up, and there's this query set alert potential geofencing crossing. So I compare all the locations that I have from the companies with the data that comes in. And if you have a query like this, here you see all the crossings, you can say, well, set it as an alert. And it will ask you, okay, what do you want to do? I want to run this query every 5 minutes. And if there's something in there, I want to have an action. I want, for example, have sent an email or put a message in a Teams channel, or you can actually do stuff with notebooks. You can actually start executing logic. And there's even support for Fabric Functions, which is a kind of Azure Functions, but without a trigger, and it's in Python. But this part is growing. This is really interesting because now you can have a fully automatic loop of data coming in, and every 5 minutes you query your ass off on the data that comes in. Within seconds, you get an answer over billions of rows, and you can integrate it with context data. How cool is that?
Is
And
it, Sander? Is that just taken out of your fabric consumption, or is there a cost separate for running those alerts? Because that's going to run a job every 5 minutes.
yes, the same goes for the Azure Data Explorer, which is a cluster. And the
Hmm.
same goes for the Azure Stream, the Stream event stream, which is a Azure Stream Analytics job. Those are all pieces of compute. So
Yeah.
it's not when I push a button that something is happening and that will be a piece of your capacity usage. No, it will run day and night. So you will not run this on an F2. There's a article on how much consumption a event stream will be, for example, or an event house. Don't take this lightly. But again, if this has value for you and can save you thousands or hundreds of thousands of pounds or euros in manpower or lost cargo or whatever, you're willing to pay that extra few thousand on Azure consumption.
Yeah.
These are not the cheapest things. I have to be. That's true. Good question.
That's like
Thank you.
running a Logic app. It's pretty much going to be like that, or running an Azure function.
Yeah,
It's
and
going to be that
well,
sort of thing.
and this activator that we have here it is. It's a combination of Logic apps and a Stream Analytics job and an Event Hub and um, how's it called? A Power Automate probably. So there's a bunch of services behind it. So if it adds value for you, work with that. So
Uh-huh.
I already added a few alerts, like is the battery low? I get an alert, or did I cross the geo fence? A geo fence. So let me figure that out. And actually, we see that today between 7:35 UTC and 1 o'clock UTC, I left the office a little bit earlier to work on this and to be ahead of traffic. I had alerts, and those alerts were sent to a run function, to a function that I had with some kind of code in there. So how cool is this? This is working as a bliss, and you can set it up in a couple of days. And of course, that's not something that will be production ready if you do the real stuff. IoT that takes a little bit longer. You have to think about security and networking and stuff and private endpoints. But the basics are there. You can have a proof of concept in days. There are even simulated data sets like bicycle rental events in London. Uh, could have picked that one also, but I went for actual data. So this is how this is working. And this is basically the demonstration that we've had, except for one more thing. I forgot to mention the functions regarding geospatial stuff. If we look at this map that I also prepared, no, the other one, this one. Um, it's nice that we can see that I entered a geofence, but how did I wrote that query for the alert? Did I figure out if it's working as expected? Well, the K-Quell query language offers dozens of location-based querying functions, like what's the distance between 2 points, or is a point in a certain polygon. So what I did, I played around with a number of functions, and I created some wait a minute. So some practice stuff. So what I did, I put in the location of the A41. That's a museum here in Eindhoven, and it looks like a real saucer, a flying saucer. It's a UFO in real. It's cool. And this is our office, so I drive by that flying saucer every day.
It is cool. Isn't that the one that's got a DeLorean in it, or had a DeLorean in
It
it when I
it
went
still
past it?
has the DeLorean also in
Yeah,
it.
yeah, yeah.
Um, and what I did, I added a number of shapes. So what we see, I put a circle with a certain distance to the E41, and I put in some polygons in here. Um, And I actually put also in the city walk. We have a city walk in Eindhoven. It's a tunnel underneath a little river. And you can actually look at John Cleese doing the city walk and you can mimic him. And nobody will see you because you're in the tunnel. So you can burn a lot of calories. I've heard it's one of the best exercises that you can do to burn fat, doing the silly walk. So I played around with stuff. And for example, this line is here. And if I do some extra stuff, I can actually also work with um, some boundaries around shapes. How cool is that? So this is a little bit on how it looks like and why did I build this. If I go to the other database, the geocaching database. How am I in the time, Pete?
Oh, it's your evening. You can
It's my
carry on.
evening.
Just until everyone
Okay.
leaves, and even then, carry on.
Because it's hard to let loose to kill your darlings. I want to show everything what's there. And if I had more time, I even would have shown Azure IoT operations, but whatever. I created a table with all the stuff that are there. So there's the A41 with a circle. The circle is a polygon. The A41 itself is a point. Um, I put in the city walk as a line string, and that's one, and these are the locations, the two locations, the two buildings that
Sander,
we
just
have.
a sec. Did you answer John's question in the chat? He's asking, can queries, alerts, and or other settings be? And do you want to say it, John, instead of me reading it out? You're right there.
Yeah, I didn't want to interrupt, so I was
No, no,
waiting
no, no.
until the end. So yeah, I'll ask. I was wondering if all the queries that you have shown and the alerts and all the settings can be stored or put somehow in DevOps. I mean, your DevOps or GitHub. And if not, how do you deal with versioning, packaging, and
Oh, that's
delivery?
that's
Yeah.
that's a really pro question because that's a question that everybody says, well, yeah, nice, but how about version control?
No, I
That's
mean the features are great, but how
yeah.
do you bring those features into a
Well,
kind of enterprise and pro context to control delivery? And yeah,
yeah. Well, keep in mind that if we go to a workspace, on workspace level, you see synced and uncommitted. That's
yeah,
because we have source control support
good,
with actually even branching.
good, yeah,
And you can say if something changes, there's Git behind it. At least I always go for Git, but I believe I expect that Azure DevOps is also supported.
okay,
And you can also work with deployment pipelines. So if you have a development environment and you have something that is interesting, I want to put it in a capacity or in a workspace that is test or production, you can work automatically with those deployment pipelines.
good. And do
Do
you have different prices levels depending on the type of environment you're using, production or development, or that can change?
That depends on how you do it. In the end,
Okay,
it will end up in a workspace somewhere.
okay,
So how
good.
you do that, it's up to you. But be aware, this is not as software development. We are looking at a software as a service solution, Microsoft rules regarding how it works. Um, and this is not for software developers. So you don't have that fine-grained control over each line. This is
Yeah, I
really
understand that.
more
The point is that separating a kind of a production environment of something that is
correct.
not
Yeah.
production, and yeah.
It's there, and
Okay.
I'm not sure if it's public it's GA. But of course, Microsoft put most of the effort in the functionality, and
Okay, yeah.
version control was second phase, and it's there already for a long time. So probably it's parts of it are already GA. But yeah, a good question. Are there any questions? Other questions, Pete?
No, not that I can see. But I mean, if folks do, then now's a good time for you to come off mute and ask, or stick it in the chat if
Yeah,
that's what you want to do, and then I'll interrupt Sander myself. I'm not shy at interrupting Sander. Sometimes you just got to interrupt Sander. You've got to
yeah,
rush.
yeah.
Guess
You
I'm
are
not.
allowed, Pete.
Yeah.
So what I did, let me just, there's too much to show. Kill your darlings is very hard for me. What I did was something like, for all the data in the Silver Tracker database, combine it with the geofencing locations that I have in this database, and tell me if those points are inside the circle of the Evoluon. And that's give me all the dots inside the circle. And that looks a little bit like this. How about that? These are all different dots, of course, but here I said I want to have it represented as a heat map. So there are some points, probably because this is a traffic light, and I'm standing still there more than in the other locations. But it can also have to do with reception quality that those messages are sent. So it's nice to do something. Wait a minute, that's the other page. Oh, wait a minute. Now I have the bar. Let me do it like this. It's nice to see the data is working, but having the visual confirmation in Fabric Maps is really useful. So, for example, this is another one inside a polygon, and I move over. That's this one. I'm not sure. Yeah, there it is. Here's a polygon. It's a polygon that I put around our building. And here are all the labels from the Evoluon. There you see all the dots in a polygon. So having visual confirmation is really great. You can also do something like the distance between 2 points. So that's the two buildings that I have, Evoluon and SDG Group building. And that's the same distance, something like 1,500 meters and a bit. We can also say, well, what's the distance from a set of points to a certain line string? So you have a line, and you can ask from a point in the world, what's the distance to that line? So you will have a angle, because that's probably the shortest distance, but it will keep track on if there are curves. So it will find the position in the line that's closest to you. How cool is that? That's another function, but here the distance between the closest line on the line and you. We also can say something like, what's the distance from a point to a polygon? I'm skipping this a little bit because it's nothing more. I want to have the intersection between two lines. Let's do that. It's the silly walk with the Doorgelo laan in Dutch. And come on. There. There it is. Those two are intersecting, and that's true because we can look at that. Let me zoom out a little bit. And it's this crossing. These two. These two are crossing. So visual confirmation. I really love this. The power that we have. And What's this? Does a line and a polygon intersect? And that's a little bit silly because both lines that I have are not intersecting with any polygon, it says. And that's strange because I had a polygon nearby. Let me check that out. And here are two polygons. And yeah, the line is not intersecting with that one. So I probably could have changed it. So I have nice visual confirmation, which is really nice detailed on stuff that I'm doing. As you can see, there's an overlap between those two polygons. Let's see if that works. And that's intersect of two polygons. And it says, yes, those are intersecting. Oh, how about that? What's also interesting is that I can have the center of a polygon. So if a polygon is really strangely shaped, I can still get the center of it.
Are those features in 2D or 3D in a surface or
These are the 2D
2D?
GPS
Okay.
locations.
Okay.
There's no height in here.
Okay.
You can also work with, and that's the line buffer. You have seen the line with a buffer around it, or with it was a broader. Let me show it on the map, of course. You have seen this purple thingy around it.
Yeah.
That's a 50-meter barrier around the line.
Okay.
So you can try to figure out if something is near or entering something, a geo shape like a line or a polygon. So if it reaches the buffer, but not the polygon itself. You can do
Good.
stuff with that. Well, that's basically what I can show at this moment. There are many more geospatial queries available or functions available in the KQL query set. This is just a subset. This is also with GPS, but there's also something like H2 and H3. Those are other ways to represent data on a map, like hexagons. It's very broad in usage. So let me continue. We've seen this. We've seen the Lorawan stuff. We've seen the portal. We've seen that one. Oh, am I going the right way? Yeah, I'm going the right way. I've demonstrated the event stream. I've demonstrated the medallion architecture. I've demonstrated the maps. I've demonstrated the extra layer with the tile set. The heat map, we've seen that, and all the query stuff that we can do. And I've demonstrated the activator. But that's not where I stopped it. And I also advertised that we should talk about ontologies. Because at Ignite, Microsoft introduced the IQ, which is a new part of Fabric. It's ontologies and data agents to work with your data in a more clever way. And let me demonstrate that with the data agents. So before we dive into the ontology, if I go to this one. Oh, wait a minute, I have a separate tab for that. Oh, there's too much stuff. Here it is. This is data agents. It's a service that I start, and I can, it's like an agentic environment, so I can ask queries about data that I have, and I can add data sources like the KQL database with the ambient data and the tracker data. So I already created a few questions this afternoon. So I can ask what's the latest position per tracker, and it will actually show the latitude and longitude for each tracker that I have. Just to show that it works, I can ask it again, and it will start answering that information. And it knows that tracker probably means the silver tracker table. And actually there it says, no, this one is a little bit older, but this one is actually communicating still. So I have the locations. So what I did I have the positions. Give me the most visited places over the last 24 hours with a precision of 100 meters. That's a nice question. And it said, well, okay, looking at the data, at one position, most visit 600 times, and I can actually figure out which KQL queries it used. How about that? It's actually doing a lot of stuff on figuring out how to get to those questions. And then there's a silly thing. It says, let me know if you would like these on a map. Yes, of course we want to have that on a map. Why not? So make it so. So I said, put these on a map. Well, okay, that's a bit silly because then it says, well, here are the links with Google Maps where you can see the locations. Okay, that's a little bit of a bummer, but okay, nice try. Then I asked, okay, are all these locations visited by the same tracker? And then it went into a problem. It said the data query didn't work out. So something went wrong. But then I said, hey, try it again. Sometimes you just have to push it, give it a little nudge. And so I said, do it again. And oh, now this time it actually shows which locations are visited by both or by a single tracker. How cool is that? You can ask questions in natural language. And then I said, well, okay, can you put a street name and a city on it? Hey, it's an agent and it has agentic information, but then I say, yeah. That's a little bit of a thingy. You have to do geocoding. Okay, then I said, well, maybe you can at least start with a city, because I've seen in the past cities are known and it actually works, because this is near Eindhoven and my son was near Utrecht. Actually, he was near Maarsen. So how cool is that? And then I said, hey, wait a minute. I have tracker information, but I have also relational context data in a lakehouse, tables with data about a demo factory. So I have a demo factory with production line data, and production line are operated by operators, and there's a work order for technicians, and technicians are having a positioning sensor in their car, and the production line have ambient sensors. So I said, well, what's the relationship between a positioning sensor and an operator? So that should be operator, production line, work order, technician, position sensor. Well, it says, well, I have no clue. Because this is quite hard. It has to figure out that the line here from an operator is related to the production line ID over there. So being able to work this out as a graph, multidimensional relationships, how cool would that be if we could do that? And that's actually what is offered by Microsoft in Ontology. So if I go to the right workspace, Ontology workspace, and I have built up an Ontology already. And this is it's in public preview, so that not everything is working. We will see, but it's really nice. If you've seen Azure Digital Twins, it's a little bit the same but differently. If you work with Digital Twin Builder, which was in public preview, this is the predecessor. This is the better solution. because there's actually a graph underneath it. But for example, the production line, it's a entity, and the entity has a number of columns, properties like the ID, what kind of product is created on the production line, what is the grade, and how does it know that data is there? Because I made a binding with a table in a lakehouse. So that's how it works with a entity and with a, um, a lakehouse table. I also have an operator, which has a name and a line where it's related to. And as you can see, do you see the arrows? Those are relationships. I can describe a relationship. For example, operator. That means that the operator ID, sorry, that's not true. The line ID is related to the production line ID. That's what I can describe. That's a thing that I have to do once, and the same goes for a manager. If you look at the operator, it has a manager or not, so there's a self relationship in here. And that's all quite static information. But how about a sensor, like the positioning sensor? I created a table with all the sensors, and here you can see the sensor ID and the sensor type and a description, and those are static. Those are coming from a lakehouse table, but there's also time series data, because if we look at the bindings, there's the lakehouse static data, and here's the time series data coming from a table. At this moment, the table, maybe queries will also be there, or functions, but at least it's coming from a table in my event house, in my Azure Data Explorer time series database. So you can actually add multiple sensors together as one big sensor thingy. What it does, you just fill in the overlapping sensor properties, and you add new properties for the new sensors.
Can you
So
use ontologies defined somewhere else or import them, or you truly need to define them inside Fabric?
I have to, and that's something that a data engineer should do. Only once I have to build up this ontology. So I create all the entities, I create all the relationships, and I have a graph, and here we see partially a graph of a production line with
Yeah,
its relationships
but
with the other ones.
but can you base them in a standard, a standard ontology from the market and import them, or you need
Oh,
to
at
redefine
this
everything?
moment, not. That
Oh,
feature is not available because
okay.
you mentioned earlier that you're working with DTDL.
Yeah.
How cool would it be if it supports DTDL?
Yeah, very good. And even though even better, if it could support other standards in the market
Correct,
besides DTD.
correct. Like real estate core, for example.
Yeah, for instance, and yeah,
That's a standard for ontologies. There are
yeah,
multiple
yeah,
standard ontologies in the market.
yeah,
How about importing them just in one go? That would
yeah.
be really great. Then just you connect all the data and you're up and running.
And
So
even having a kind of repo of ontologies and to pick up the one you want, because
yeah,
maybe
yeah.
people don't know them, or so it's
Um,
yeah.
there's a Fabric wish list. You can put your wish on the list. So make
Okay.
use of that. Let's go one step further. And here it breaks for me. I will show you what happens. What I'm hoping for is that I get a graph-like experience in here, and I get actually line charts for humidity, and a line chart for temperature, and a line chart for light. But those are broken at this moment. They will go corrupt at some point. And actually, if I expand this one, I will see that there's a graph-like experience. Thanks. Let me add all the relationships. This is Fabric Graph. This is part of Ontology. Ontology is based on a actual graph experience. So we see the self relationships, and we can use a query language to turn this in the actual entities, because there are something like 10 technicians, and I have 2 production lines, and I have 10 operators. And how are these actually related? That could be shown in a diagram view. Only if I run this, also this will break. And I'm very sorry, because this is the essence of doing something with a query language. The actual underlying query language looks a little bit, and this is the give me everything, but it's the graph, the GQL graph query language for working with a graph ontology. But it's also, this is broken. I think this is actually the problem underneath ontology at this moment. Maybe they will fix it in a few days, or I have to reboot everything, and maybe there's something wrong in my thinking. But I made a few screen dubs up front, so sorry about that. But as you can see in the left lower corner, we see actual the lines. Fun fact is that GPS locations are also shown as a line. So you will see the GPS location, the latitude and the longitude as 2 lines. That's not really handy. I want to have a map. So the map is coming. And we see the ontology over here. And we see the actual graph that is generated when I hit a button and it works. So this is the twin cloud with all the instances behind the graph. And so I can query all the relationships which are there at this moment, and combine that with the Keiko query language for the time series data behind it. Or, and it's not working, but that's the coolest part. The agent that we've seen a few moments ago, there's also support for an ontology. So this data agent that I run now is having the ontology. So now if I ask a question about, can you tell me something about all the relationships? It actually knows that an operator is connected to a production line, to a technician, to a work order, to a positioning sensor. How cool is that? So the promise is there. Sorry that the demo broke, but this is the coolest part. I think that's really, really cool. And I can
Is there an
start.
endpoint for that agent, Sander?
That's a good question, because once you have built your agent and you can start ask questions, well, that's cool, but how can I ask those questions in an automated way? Well, Microsoft is offering a publish button. And if you do that, let me say publish. Let's see how long that takes. In that case, I can go to the settings, and here is actually an API available. So you can make this agent part of other agents, or you can reuse this agent in Foundry. How cool is
Okay,
that?
that's
And
good. Okay.
then it acts like an MCP.
So you can see it from the AI Foundry portal directly, or
I've seen a demonstration where it was consumed by
Okay.
in the Foundry in Foundry.
Good.
But basically, if you have the credentials, you can. It's an API, so you can just.
Yeah.
I think
Yeah.
it's RESTful, so you can just consume it. How about that? That's really cool. So, um,
Any idea of the cost of using that model for that agent, maybe?
the agents are executed when you call them, and that's when you pay for the consumption.
Yeah,
Um,
but how much?
no,
Do
no,
you know
no.
or no?
I have no clue. But keep
Okay.
again, if it adds value for you, then you're willing to pay this. These are not the cheapest solutions, but
Yeah.
okay. This is all about data engineering, and that's on the value side of a solution. And the IoT Hub is on the cost side. It must be as cheap as possible, but
No, I mean,
when it adds value,
yeah, most of this is valuable, but the point is that not all the companies can have return on investment on that, or not all the
no. But
companies can pay the
start small.
first.
Start
Yeah.
small. Try to understand if it works for you. There's a let me do that. Let me pick that up later on.
Okay.
First of all, there are new things coming for maps. I spoke with the product team and they showed it in another solution. There's a time slider coming, so you can go through position data related to time. Images, you can add images to the map. You can use other icons than bubbles. So a ship can actually have an icon of a ship. The styling can be data driven. Think about I have now a list of shapes, but they all have the same color, but each line gets its own color, something like that. MSG support and job scheduling. And there will be more, of course, much, much more. And that brings us to the call for action. First of all, you've seen Lorawan, really cool with all the sensors and the gateways. Uh, cheap communication out in the open. Um, cannot say enough about it. So figure out how that works and also figure out the things network. Then the IoT Hub is back in action. It's not feature complete anymore, as demonstrated by Pete. And also look at the other stuff. If something triggered you together today, like Azure IoT Edge or Azure IoT Operations, just reach out. We are happy to help you with that. And John, your question about Microsoft Fabric, if you want to learn about it, go for a trial version. You can get a F64, which is quite expensive if you have to pay it for it, but if it adds value, and you can start as low as 250 euros, something like that. Don't say I'm
Okay.
wrong, but in that region, and then the price doubles for every size. So then you can calculate from an F64.
Yeah, good.
The F2 is something like 250 euros. I wrote a bunch of blog posts about doing stuff with Fabric RTI. There's so much more in Fabric, but okay, I limited myself to this part because it goes so well on top of IoT. And if Fabric is really your thing, go to the Fabric conferences. Why not? Let's go to Atlanta.
If someone's paying, I'll go.
Yeah, yeah, yeah. If it adds value.
Yeah, yeah, exactly.
So, with that, thank you for having me. And thank you for having an elaborate demo. And if there are any questions, you can go unmute and ask. I'm
Very
here.
good,
So
Sander. Very good.
Yeah, thanks for giving me another rabbit hole to fall down.
you're welcome.
Must protect my debit card from another hobby.
Yeah, these meetups are dangerous.
Yeah, quick, buy all the kit. I need 6 Raspberry Pis.
Yeah, it's true. I see there's a new AI hat too. AI Hat Kit Plus 2 out today as well. I don't know if
Can't
you
tell
spotted that.
that.
It's more
No.
expensive than the most expensive Raspberry Pi, that one hat. I think it's 120
Right.
something quid. I was umming and ahhing because I do actually use that, and I've got a few talks based on that. So I was tempted to go buy one, but I can't justify it at the minute. But it runs LLMs locally on the NPU on that hat. So
On the
yeah, well,
Pi?
on the hat. So it ignores the Pi, so
Yeah.
it leaves your Pi free to do the IoT stuff. But you can, a bit like what Sander was talking about, you can do your LLM and host that locally now, which is pretty powerful.
SLM,
Damn you.
small language model.
Well, I think it's an LLM. It's not even an SLM. It's
Oh
an
yeah,
actual
of course,
LLM.
if you have more room and more
Yeah.
memory. But memory
It's
is
got 8
quite
gig on board.
expensive.
It's got another 8 gig of RAM on the hat.
Okay.
That's not bad for 126 quid then, to be fair.
Not with just the RAM would be worth that much.
Yeah. Yeah. It would.
Yeah, I was very
Sander,
tempted.
you reminded me, I actually have one of those gateways.
Yes.
And I haven't actually used it for years. I even forgot that I had it, to be honest with you. But I'm intrigued by the fact that it actually has an interface to the IoT Hub. What's the range can you get? Because this is actually defined as a indoor, right?
Yeah, that's the range for this one is something like say 50 to 100 meters. But if you have line of sight, it can go to 300 or 500 meters.
Okay. All right. Great.
So
Thank you.
and it has a USB-C
Yeah, I know.
and
It does.
and
Yeah.
it connects over Wi-Fi. So with a telephone
Right.
and this, I have a local gateway.
Okay, cool. Yeah, because I was thinking maybe what I'll do is to use it in the Things Network for the community. I might actually put it up high, like because it has a USB, so put it somewhere where actually it almost is an outdoor antenna, and that
Yeah.
actually might be able to
There
extend its
there
range.
there are people who open it and soldered a fixed antenna on it.
Okay,
And
I
they
could
put
do
it
that.
in a
That's
cap,
true.
and then it can be an outdoor antenna. But
Right. Okay, cool.
but
I'll look into it.
maybe
Thank you very much. I appreciate it.
gateways go from 100 euros, something like that. And an outdoor is something like 500 or maybe 1,000.
Yeah, I noticed that they had a newer model with like two antennas on it.
Also, yeah, but keep in mind, if you do outdoor on a building, you will pay much more for lightning protection. The
True.
cost is not the gateway,
Yeah, right.
Love it.
Right.
and having a people on top of a building, that's not something a janitor really likes.
No, that's true. Yeah.
That you have to replace the SIM card or whatever, or reboot it.
Brilliant stuff.
But yeah, this is really, really nice. By the way, it's also just powered by
Yeah.
a wall socket if you want to use
Yeah,
that.
that was a good part of the design, the fact that they can, they have the USB-C as well as the wall plug.
Yeah, but well, it's a Dutch initiative, the things that work. But I think they thought ahead with the European connection wall socket and the American. But you're in Canada, so
Yeah, I'm in Canada. No, I actually have the North American. So I got the
Yeah.
version that's it's capable, I think, of both voltages. It's
But
it's
Single
it's-
frequency though, isn't it? I think you have to buy the
no,
one for the
no,
right region.
that's kind of an issue
Yeah, I'm
because
looking at the back and it says that it's both. It's 100 to 240 volts, 50 or 60 hertz. So
yeah, but which
The band,
broadcast
actually.
frequency?
Yeah,
Oh,
the band
oh,
rather.
right,
Yeah, sorry,
right.
frequency was
Okay,
an
I'm sorry. I
overloaded
thought you
term.
meant this power. Yeah.
Yes.
Because
Because
it's
I made the mistake.
in-
I bought the wrong one first and I had to send it back because I bought the US one, just clicked the button and ordered it.
That's
and
the 915 megahertz, and we have 868. Although there are some changes, it could be that the American frequency is also coming available in Europe or the other way around. I'm not sure.
I've used it like maybe 5 years ago, to be honest. So
Yeah.
it does work for me. It just I didn't realize that it had an interface to the IoT Hub because I don't think it did at that time.
I think there's a couple of videos on my YouTube you'll find somewhere where me and Ben Carbe, who was at Microsoft at the time, did a 3-part Twitch around getting this all set up to be able to do it, and we did an end to end. Having said that, it was probably 5 years ago, and so it's likely changed a little bit, but it was Things Network. And we did the whole end to end of how you onboard it, because it's actually more complicated than you think, and you have to make sure when you get your devices that they give you there's a key or a passcode that
Yeah,
is
but
synced to that.
nowadays there's a device registry, and you just can pick your device from a list, and everything is filled in. You only have to fill in some secrets on the back of
Yeah.
your device, and even that can be done with scanning or whatever.
Okay.
So the enrollment of devices is much easier than back in 2016, 2017. No, LoRa is really interesting, and as I said, I was really surprised that I've got connection with gateways above Germany when I was in
That's
a
amazing.
commercial airplane.
Right.
No
30,000
clue,
feet.
and the tracker was on my rucksack, and that was in the cabin, or how's it called?
The overhead.
The overhead.
Wow.
How? But it worked.
I remember it's been years now, but I remember that, some people were actually testing how far it could go, and it was significant. It was actually very significant.
The LoRa one protocol. There are attempts with hundreds of kilometers,
Right.
which
Yeah.
is
We mentioned earlier that Cliff Aegis, another fellow MVP, is a pilot, a captain for BA. That guy warns people not to put AirTags in their luggage like people were doing before, because they can get destroyed, and not just the AirTag, your entire luggage. So if you'd have put that Lorawan device in your luggage, there's a possibility, because I think they're checking for radio because of the obvious problems with that. So be
but
careful.
it's the public frequency.
Yeah, I think AirTags are running on the same public frequencies, but any radio transmissions from your luggage will probably be
Yeah.
taken
Yeah. Okay.
seriously.
I don't want to make people more intelligent but I can figure out why.
Yeah, exactly. So yeah, be careful with doing things like that. But that's cool that it worked. Amazing that it worked, really, because what is it? Is it 30,000 feet or something you're up at? And it was working over that distance?
Probably. I don't get information about the height because I had no fix with the GPS. I only had a fix with the communication between the tracker and the gateway, the gateways, multiple gateways. So I got a fix on Prague. So
It,
it's
it,
because from the Netherlands they go with a half circle.
no, it reminds me of, it shows you just how much of a geek I am. I used to take my Garmin navigator across the Atlantic, and I would like put it up against the window of the plane and actually turn it on. You could see, actually it would synchronize with the satellites, and you could, just see yourself going at, 600 kilometers an hour or
Yeah,
whatever it was.
yeah, been there, done it. It's
Um,
really geeky. I wanted to record all my travels. I went to Canada back then, and I recorded all. I always had my GPS tracker running in the camper that we
In the
hired.
airplane, yeah. Even though I don't know if that was allowed, but it's a receiver. It's not a transmitter.
Correct,
I'm
correct.
going to stop the live stream now. Jan asked before I do, though, what the actual gateway you were using there, and I pasted a link. Connected Things store for that. I think it's that same gateway there, or very, very similar one. I think it's that one that I bought, maybe. So there's a link in there. But I think Jan's gone. But if Jan, you watch this back, you'll find that it's
It
from the
is.
Connected
Yeah.
Things store. But you won't find the link in that. So YouTube won't help me there, but yeah. Cool. Right, let's stop that live stream. So thanks to the folks that are watching this back at some point in the future. Thanks so much to Sander. Apologies that my talk wasn't part of this recording. YouTube issues trying to get that to work. But nonetheless, there'll be another version of mine coming up soon with everything in it as well anyway. So it's all good. And yeah, so